All right, hello again. This is the 10th Dart and Flutter programming lecture of our video. And then we were discussing about classes and inheritance and polymorphism and overriding and how they are related to one another. So we have seen how to create a class and how to extend that class to add more functionalities and more methods through the question and choice question classes, and through that example we also see we also saw how we can be able to override a method which allows us to have polymorphism. So we'll see more of these characteristics and other advanced materials in this class. So before I go on, I would like to say one thing. So if you remember our chapter 4, we say that encapsulation is one of the 3 pillars of object-oriented programming, right? But the other 2 pillars of object-oriented programming are inheritance and polymorphism. So this is what I mean by that. The 3 pillars of object-oriented programming are encapsulation, inheritance, and polymorphism. The rest of the concepts of object-oriented programming depend on these 3 concepts. Encapsulation is the process of hiding data from outside and then accessing them through a public interface, or what we call the methods. And inheritance is the process of extending the functionalities and methods of superclass into subclasses or different classes. And polymorphism is the characteristics of having one method or having one variable to act in different ways, and using this we can create, or using these characteristics we can create different other behaviors of object-oriented programming. The first thing that we'll see is abstract classes. What are abstract classes? Abstract classes are partial implementations of a class. So they are just small parts of a big class, or small implementation of a bigger class. So it will implement just parts or some few methods of the class, and the unimplemented parts of the subclass, the superclass, are left for or are left out for the subclass. Abstract class cannot be instantiated. That means you cannot create an object from an abstract class. You can have one or more or 0 or more abstract methods in an abstract class. And an abstract class is defined using the abstract keyword. It is used together with inheritance, and it can have abstract methods. Okay, abstract methods are methods without any body implementation. That means the methods will not have body implementation. They will just have a name and a parameter. Okay. Also, it can have abstract classes can also have normal or concrete methods that we create, the methods that we have already seen. And Normal class is not allowed to have abstract methods. That means methods without any body. So when the parent class has abstract method, the child class is required to provide the implementation. They can declare the method name, but the implementation is done in the child class. Otherwise, the subclass also becomes an abstract class. And if a class has one abstract method, it should be declared as an abstract class. So abstract class depends on abstract method. Okay, so this is kind of the relationship. Abstract class depends on, or the abstractness of a class depends on the abstractness of method. What is an abstract method? An abstract method is a method without any body implementation. We'll see that in an example. Okay, that is the best way. So take a look at this example where we have one abstract class, and then we have two classes extending that abstract class. So the class is employee class, and the abstract method is get employee info. And then you can see that the method has no implementation. That means there is no brace or there is no arrow. So in this method, it is not engulfed or braced with curvy brace, or there is nothing that seems like this. So that means this method is not implemented, or there is no body of this method. What we do is we created another class which is called manager, and it extends the abstract class employee, and this method is implemented here. So get employee info, I am a manager, and also another method, okay, another class called the engineer class actually extends employee. Then this method is now implemented here. So I am an engineer. So you can see that this is also part of actually polymorphism. That means we have one method and has different forms. One method has many forms. So this is part of the polymorphism concept we've discussed in the last class. So you can see that when get info is used in manager class, it says I am a manager, and when it is an engineer class, it says I'm an engineer. So we can easily implement this in Dart in JDoodle, and we'll see that soon. When it is a simple class or a simple example like that, it's also nice to try and write your code by yourselves instead of copy pasting, because it will help you relax and get your hands accustomed with writing Dart class. So we can say abstract class employee, and then in here we can have void get info and no implementation here. Then we can have class manager. Remember that at this point you can see that when I'm creating class, I'm using capital letter to name my class at the beginning. So I can say extend this employee, and then I can say void get, or I can just copy paste this, Control C, Control V, and then it says, or it prints I am a manager. And then I can easily copy paste this, trying to say engineer, and then I am an engineer. Then I can write my code, my main function, like this, and I can create what you say, an object of each class, or I can create I can instantiate an object of each class. So I can have manager M assigns to new manager, and then engineer E assigns to new engineer. Then I can actually call E dot get imp info, and also Control C, Control V, M dot get imp info, right? And if you run your program, then you will see I am a manager and I am an engineer. So you can see that by using abstract class, then we can be able to have a well structured or a very consistent class. So because getting employee info or getting employee information, whether he is a manager or an engineer, have the same characteristics or have the same behavior. So it is nice to have a similar name and more readable and understandable name. So we can force other classes to have consistency using abstract classes. So so far we've talked about abstract classes and inheritance, but abstract classes and inheritance can only allow us to inherit or to get the behaviors and methods of just one class. How about if you want to inherit multiple classes or have the behavior of multiple classes? That means, suppose a child has two parents and his parents get a divorce, right? So his mother has some money, his father has some money, right? So in this case, the child can get the money from his father and he can also get the money from his father, and then he can do whatever he can have their property or money, and then he can override their property, or he can override their money, or like replace their house with another house, just like overriding. And also he can just inherit and live in that house. So similar thing, what if you have multiple parents and you get inheritance from multiple parents? So that is done using interfaces. So an interface is somehow similar to abstract, but an interface is a model or a prototype class that other classes has to conform or has to follow. Okay, and the difference between an abstract and an interface, or an abstract class and an interface, is that in interfaces there is no normal method. Okay, there is no normal method implementation, and the subclass must implement always. In abstracts, the subclass can or cannot. may or may not implement all methods, but in interfaces, or when we talk about interface classes, we have to implement all of the methods. And it is unlike abstract. There is no keyword such as abstract to declare interfaces. Rather, we know that a class is an interface if other classes implement it. Okay, if there are other classes that has to implement it, then we say that, oh, okay, if this is like, okay, class employee implements person and profession, that means because of this keyword implementers, we know person and profession are interfaces. Okay, so let's take a look at this example. You can create a file called employee interface, in case you know how to install IntelliJ, but for now just forget that. So what you have to do is you can create an interface. Take a look at this interface, class person, and then in this class person we have name and age. This is the same for every person. Then we can set person name, we can get person name, we can set person age, and we can get person age. And also a person can be an employee, or a person can have a profession, something he can do or something he will do. So in this case you can see that the class profession talks about the profession of the person and the salary. The salary can be set, the salary can be get here in this case, and the profession can be set and the profession can be get. Notice one thing here, okay? What you notice is that instead of using such kind of void get person name, in Dart we have keywords such as set and get. We can use easily get person name and set person name. So now instead of this becoming, or instead of these behaviors becoming the part of the definer, they are the keywords that we can use to make a method a property. Okay, so this is another thing. Maybe when this is actually when you become more and more advanced, you can write with such an ease. So this is for your lab practice. So the employee interface is given to you. You have been given such kind of interfaces, and then you should have a class such as this class employee that implements person and profession, and each method is implemented in the employee class. So you create an employee class, as you have seen earlier, that implements person and profession interfaces. You can get the method return values and use the return type during implementation. That means when you, for instance, this person name is string, so the return type is string, and person age is an integer, so the return type is an integer during implementation. So what you have to do is create an employee class like this, employee class, that implements person and profession, and the body of these interfaces will be implemented in that class. So that is your task. And when you create a driver module or a test module like this, you can create an employee object. You can set the behavior of that employee, and then you can print the behavior of that employee. So you can see that Dart implementing multiple interface examples. if I say person name is 30, age is like this, and his system analyst and his salary is $25,000, then you should be able to print this by invoking imp.person name, imp.person age, imp.profession, and imp.salary. So you can see that at this point you can use the same property without the brackets in order to set and get the name. Okay, there is no need to use two methods. You don't have to use like set and get. You don't have to say set and get because you use the keywords set and get. I have already implemented the employee class, so it will be something similar to this. So the person class and profession class are like this, and then the employee class is for you to implement, so I will not open that. So if you do this and you execute your program, you'll have something similar to this. So your task is to implement the methods, all the methods, okay, all the methods of the person class and all the methods of the profession class. Otherwise you'll get an error. So that's it about abstracts and interfaces. But the last thing about inheritance, or the last concept about inheritance and polymorphism and classes that we should know is the mixins. Mixins is the way to use classes, or the way to use methods of other classes without implementing them, or without having to be related as parent and child to that class. Okay, so these mixins allow you to use methods of other classes, even if they are not the parent class. Okay, even if they are not the parent class, you can use these mixins. And also mixins can be used to allow multiple inheritance. So when you are using mixin, unlike interfaces, mixins does not force the implementation of the inherited class. Okay, so earlier we say that, okay, class engineer extends employee with person and profession. Okay, with this keyword with is used to mix. Okay, it's just to mix, as you can see here, just to mix other things. So the information of this person is, I'm an engineer. So, and when you use mixins, you don't have to implement. Like for instance, this is a class called engineer, right? I am using interfaces person and profession, but I do not implement them. So there is no need when you are using mixins. So this is the more advanced concept with classes. So if you are familiar with C++, this is similar to friend of a class in C++. Okay, so this is about inheritance, polymorphism, abstract and interface classes, and how you implement and interpret superclasses and subclasses. And you'll have some exercise maybe at the end of this chapter. We'll talk about that later on. But now let's go ahead and see how you can be able to design a class. Okay, when you are trying to design a class, the first thing that you should know, or the first thing that comes to mind, is the relationship between classes. Okay, because normally when you are programming, especially in Flutter or Flutter, more appropriate pronunciation, you do not work with a single class. you work with multiple classes. So knowing the relationship between these classes is very important. So the first one is just dependency. And this dependency shows that some class accesses another class. Okay, a class depends on another class if it uses the object of other class. For instance, the cash register class uses object of the coin class. Or when you declare, maybe say class class student, and then here maybe you will have string name. In this case, actually the student class uses an object of a string. So we can write this as student uses string. Okay, so student class depends on string object. Or maybe you can have a set of string and then courses. Right? Student now also depends on set class. So this relationship between the new class you are trying to create and the classes that already exist is a dependency relationship, and class depends on another class if it uses object of another class. The second is aggregation. Aggregation is when a class has an ownership or a composition. So a class aggregates another if object contains object of another class. So for instance, choice question is, or a quiz has a question, right? And then a question has what? A question has free form or a choice question. So a quiz can contain information about a student, and also it can contain about or it can have a question class. So this is aggregation. That means the superclass aggregate. And then finally the relationship between the class is an is-a relationship. That means one class inherits methods and behaviors of the other class. We already see this. And a car has a tire versus a car is a vehicle, right? A car has a tire, but car is part of vehicle, or car is vehicle. So the relationship, when it is an inheritance, we call it an is-a relationship. So when you work with multiple classes, you have to know this relationship, whether it is a dependency, an aggregation, or an inheritance relationship that the two classes has. And when you design a class, I've already described how you can use a table in order to identify the tasks, and then for each task you create method, and then for each method you create the data that is associated with that method. I've already discussed how to design a class briefly in the chapter 4. So this is just simples, and so this concept says that classes should be loosely coupled. The meaning is that the too much dependency of class or too much relationship between classes is actually not a good programming. A good programming is you can have the same number of class, but their dependency is very minimal. And this is what the symbols of relationship between classes looks like. So let's jump in and go to CRC cards on how we can use CRC cards in order to be able to design a class. What is a CRC? A A CRC describes a class, its responsibility, and its collaborators. Okay? So if you remember our discussion, this kind of table allows us to create a class. The task is addition. Then if the task is addition, then we need a method called add. And then this method may be interacting with variables number 1 and number 2, because the variable number 1 can contain the number to be added, the first number to be added, and number 2 can be or num2 can contain the second number to be added. So this is how we create one class. Okay, this is how we design the properties of that class. But how about the relationship of those classes, or how about the association of those classes? We can use the CRC card. So the CRC describes the class, responsibilities, and its collaborators, and it uses an index card for each class. And you can pick the class that should be responsible for each method and write the responsibility onto the class card. For instance, we can have a class called invoice, and then this class has the responsibility, or this class has the responsibility to compute the amount of money that you have to pay, or the amount due. And then the collaborator, or the class, the other class that has to work with this class, is line item. Then let's see how we can design this collaboration or association of classes by trying to create an invoice printer, or a class that prints an invoice in a cash register. So an invoice looks like this, right? So it has an invoice, it has the address, and it has the item of each, and then it has the total amount here. And this is what normal invoices look like. So what is the task? The task is print out an invoice. It describes the charge and the set of products. For now, we omit some complexity such as dates, taxes, and invoice and customer number. We omit those, but we can include them later on. And then we print the voice, which contains billing address like this, line items, and amount due, or the total amount. And then for each line item, that means for each product, we have description, unit price, quantity ordered, and total price. Okay, so for simplicity, we do not provide a user interface at this point, so we just can create an add line item to invoice and then just print it. So how can we discover what classes we should use for this program, or which classes we should design in order to create an invoice like this? What we do is, when we are given some task, or when we are given some job to develop a program, the first thing is to discover classes. Okay, how do we discover classes? We discover classes by listing out possible nouns. Okay, so in this case, what are the possible nouns for this task, or for this job? We have invoice, addresses, line item, product, description, price, quantity, total, amount due. All these things are possible nouns. That means all these things can be classes. However, everything cannot be class. So we have to analyze all the classes. Line item is just records the products and the quantity, so it cannot be a class. It just be part of it. And the description and the price are variables of product class. Quantity is not an attribute of a product, and the total and amount due, they are computed. They are data to be computed, not stored anywhere. So after this reasoning, or after this analysis, you eliminate or you discard some of the nouns, or you remove some of the nouns, and you are left with invoice, address, line item, and product. Actually, as you become more and more experienced with programming, you will know what nouns become classes and what nouns doesn't become classes. So you are not. I'm not gonna expect you to be an expert on knowing which is class and which noun can be class and which noun cannot be class right off the bat. So yeah, you can create CRC card for each classes that you have already discovered, and then you can see that now maybe we have the two classes, invoice and address, must be able to format themselves. So we have these two classes, invoice and address, and we know that actually invoice collaborate with addresses. Okay, and then we can go ahead and also create other CRC cards such as product just get the description and the unit price, and line item creates just the format of the item and the total price. And then all the product, line item, and addresses classes are collaborating with the invoice class, not with one of them. Like, okay, the line item also collaborates with products actually, but this is the main class, the invoice class, that collaborates with address, with line item, and with product. In this case, now this can only tell us these three classes works with invoice class. Is it an inheritance, or is it has a or uses a, or is it an is a relationship that these classes has? You have to figure out too. Okay, I think in this case invoice has a or uses a an address class, uses line item class, and uses product class. So it is dependency. So invoice depends on address, line item, and product classes. So that is how you create the relationship between classes. So first you have to know how to create a class. Then you have to know how to develop the relationship between classes. Okay, so what are the well-designed, or the behaviors of a well-designed class? So all our goal is to create a class or a program that is well-designed. Actually, a well-designed program has a well-designed classes. Okay, here are the features of a well-designed class. So it hides all implementation details. That means all variables of your class can be accessed via methods or via public interfaces in this case. So methods and public interfaces are actually something similar. So methods can be private and public, if you remember our discussion, right? So the public methods are called public interfaces. So you can access the instance variables of a class through the public interface. That is called hiding the implementation detail. So a well-designed class has to hide the implementation details. It uses abstract class to separate its interface from its implementation. So that means it has to have some abstract class in order to show, or in order to make more consistent programming. Communication, or it communicates with other classes only through their interfaces. That means only through their public interfaces. Okay, only through the methods that are public, that they can interact with other classes. And all these preceding properties leads to encapsulation. Why encapsulation is important? Because if a class is designed with encapsulation in mind, then a class can be developed, tested, modified, and used independently. That means if it can be tested, developed, modified, and used independently, that means this class appreciates, or this class supports decoupling, or it supports the loosely coupling concept, which is a good behavior of a class. And the programs can be quickly developed because classes can be developed in parallel or by a different person. Class optimizers can be done without affecting other classes. That means if I'm trying to optimize my class and Professor Kim wants us to optimize his class, then we can do it independently, and classes can be reused more often because they are not tightly coupled. Okay, encapsulation and this behavior leads to less tightly coupled class, which is a good behavior in classes. And success in development of each class leads to success of the application or the program or the software that you want to develop. So we discussed about functions, like when we started with modularization, right? We started with functions, then continue with classes. We talked about abstract classes. We talked about inheritance. We talked about interface, overriding. We did not talk about overloading. Yeah, we did not discuss about overloading. Actually, that's concept of other programming language. In Dart, we do not support so far overloading. So the reason why we discuss this kind of concepts is because we want our code to be reusable, readable, consistent, tightly coupled, and have a wonderful program. Okay, not a wonderful, but have an efficient. Yeah. That's the word I'm looking for. So have an efficient program. And if you remember, we said that an efficient program uses its memory properly. So everything we do here is the reason why we have classes is because it will allow us to program more efficiently, and it will allow us to bring real world experience onto the computer, or real world objects into the world or into the computer world, such as, for instance, quizzes we know with paper and pen, right? But we can give quizzes online, or questions, or tally counters. Tally counters are mechanical objects. We can make them application software. But mind you, there are things that can be automated, and there are things that cannot be automated. Driving a car cannot be automated, right? Like, you cannot drive a car inside the computer. So you have to know the limitation as well. You can represent a car in computer, and you can write a software for that car, but you cannot drive a car in the computer. So you have to know the limitations. So these classes, anyways, the concept, the moral of the story is the class and objects and functions all of these things allows us to develop a very efficient program which uses or which utilizes its memory efficiently. Okay, so that is also a part. So code is reusable, consistent, and efficient. So we have to add efficiency and tightly coupled. So we have, so that code is memory efficient, and tightly less tightly coupled actually. So we want our code to be all these things. That is why we learn about modular programming and other things, and also the conditional statements, the for loops. That is the main goal. The next discussion is on how to handle error in computer program. I will discuss that in the next video lecture.